falling body is defined as the vertical motion as the body at constant acceleration under the gravitational field without air resistance. Okay, so free falling body actually we assume that it's a vertical. Okay, jatuh bebas. Okay, in the Earth gravitational field, the value is constant and the value is always equal to 9.81 meter per second square, and the direction is always towards downward. Okay, so that's why we assume that our g is always equal to negative g. So if you compare with the linear motion and the free falling body, okay, so we also have four equations where linear motion where v equals to u plus at, but for free falling body it become a become negative g. So we change a become negative g, become negative g. Okay, so we also have four equations where v equals to u minus gt, v squared equals to u squared minus 2gs, s equals to ut minus half gt squared, and finally s equals to half u plus vt. Okay, so besides that, we also need to consider the directions. Okay, because when you substitute the answer inside the sign convention, you must refer back to the directions. If the motion is upward or to the right, we assume it's positive. If the motion is moving to the left or moving downward, we must put negative. Okay, so let us try example. Exercise 4, questions number 1. Object is released from the rest. So we know that our u is equal to 0 at the height of 20 meters from the building H. Determine the time and also the velocity when it reaches the ground. So again, you need to find out three informations where the first informations we have is u equals to 0, and then we also have s. Okay, so because the ball is falling downward, okay, falling downward, okay, so your s will equals to negative 20. Okay, why negative? Because the object is acting downward. If let's say this is the point that you release, so this one will be origin 0 0, this is the origin. So if you throw downward, release, move downward, you will get negative. And then another information that we need is g. Okay, g is always equal to 9.81. So we substitute inside the equation where we want to find t. Okay, so the first equations we have u, s, g, and t. Okay, so we can use s equals to ut minus half gt squared. Okay, so s is negative 20, u is equals to 0, half g 9.81. Okay, so I already put negative in front, so meaning that when I substitute, I just substitute 9.81. T squared, t is the value that we want to find. Okay, so our t, you will get t equals to 2.02 seconds. Okay, next one, we want to find the velocity when it reaches the ground. Okay, so since we have all the informations, we have u, s, g, and now we have t. So you can use the simplest one, v equals to u minus gt to find the velocity. U equals to 0, negative g 9.81. So again, I already put negative in front, so when I substitute, I just put 9.81. T is the value that we found just now, 2.02. So finally, you will get negative 19.81 meter per second. So this negative actually indicate that the object is released and it is moving downward. Okay, it is moving downward. So negative here shows that the object is moving downward with the magnitude of 19.81 meter per second. Okay, next questions number 2. A ball is thrown directly downward. So when it throws downward, okay, at the speed of 8 meter per second from the height of 30 meters. So again, like similar like just now, the ball is throwing downward with the initial. Just now, release. The first question is release. So when we say release, initial velocity is 0. But now this one is throw with the initial velocity 8 meters per second, and the height is s is equals to negative 30 because this is the origin, 0, 0 origin. So from here, you are throwing downward. Okay, and another information that we know is the acceleration equals to 9.81. So the first one, you want to find time taken. You have s, g, and u. You want to find t. So s equals to ut minus half gt squared, where s equals to negative 30, u is equals to negative 8. Why negative 8? Because the object is throwing downward. So we put negative. T, we don't know. Minus half g, 9.81. So again, you just substitute 9.81 because already substitute negative, I bring forward, and equals to t squared. Okay, so if you rearrange back the equation, you will get 4.905 t squared plus 8t minus 30 equals to 0. Okay, so if you press calculator by using the quadratic equation, you will get t equals to 1.79 second. So remember to write the unit second. And next one, you want to find the speed when it reaches the ground, meaning that we want to find the final velocity when it reaches the ground. Okay, so we can use v equals to u minus gt to find. U is equals to negative because the object is throwing downward with 8 meters per second, negative 9.81, and t is the value that we found just now, 1.79. So finally, our final velocity when it reaches the ground will be negative 25.55 meters per second. So why negative? Because your object is moving downward. Okay, it's moving downward, reaches the ground. Okay, next one, questions number 3. Okay, questions number 3 is an object is thrown vertically upward. Okay, so now your object is thrown vertically upward with the initial velocity of 20. So we put positive 20 meters per second because the ball, this is the origin, and you are going to throw upward. Okay, so it's positive 20 meters per second. Determine the maximum height. So when it reaches the maximum height, remember, when it reaches the maximum height, your velocity for y component will equals to 0 because it already reaches the maximum and it cannot move further height again. Okay, so you must remember when the question say maximum height, your v at maximum height will always equals to 0. And another information that we have is g equals to 9.81. So we want to find the maximum height. We want to find s. Okay, so which equation is suitable? We can use v square u square minus 2gs. Okay, so all this is we use y component because it's vertically. V maximum height is equals to 0. U is positive 20 minus 2g 9.81. S is the value that we want to find. So finally, we found that the S equals to 20.39 meter. Okay, and what is the time taken when it reaches the maximum height? So we can use v equals to u minus gt, where your v when it reaches maximum is equals to 0. The initial velocity is 20 minus 9.81 t. So t equals to 2.04 seconds. Okay, so this is questions number 3. And all these questions is only involve vertical motion. It's only free fall motion. Question number 4. If an object is thrown upward for the velocity 10 meters per second. So again, this object is throwing upward, u equals to positive 10. What is the final velocity v when it reaches the ground and what is the time flight. So meaning that it moving up until maximum and then it will move down again. Okay, so the first one we want to find is the final velocity when it reaches the ground. Okay, so when it from the ground, meaning that it's from origin, you go to maximum and then you go back to the origin. Okay, so the first information we have is positive 10, and then G standard 9.81. So when you go to maximum and then you go back to the origin, meaning that the displacement is equal to 0. Why 0? Because when you go up, okay, when you go up, let's say, for example, let's say 5 meter positive. When you go down, it will become negative 5 meter, example. Okay, example. So positive 5, negative 5, it will go back to origin, so you will get 0. Okay, so 5 meter is only example. Okay, so now we want to find the velocity when it reaches the ground. UGS, and we want to find V, so we can use V square equals to U square minus 2GS. Okay, V we don't know, U is 10 square minus 2, 9.81, S is equals to 0. Okay, so our V is equals to V square equals to 100. So our V will equals to positive negative 10. Okay, when you set, of course we will take negative 10. Why? Because when it reaches the ground, it will move in downward direction. Direction is downward, so we will choose negative 10 meter per second. So this is the velocity when it reaches the ground. So what is the time of the flight? Meaning that you go up until maximum and then you go down, reach the ground. So time taken, we can also use back the information UGS, and we want to find T. So we can use S equals to UT minus half GT square, where when it reaches the ground back to the origin, the displacement is equals to 0. U is 10, T we want to find minus half G 9.81 and T square. Okay, so 10 T equals to half 9.81 T square. T and T we can cancel. So finally our time taken is equals to 2.04 seconds. Okay, so next one, the final questions will be questions number 5. Okay, so this question actually is a very good question because they ask A to B, B to C, C to D. A lot of point at different point, we will have different value of the velocity. Okay, so a ball is thrown from the top of the building, is given at the initial velocity. So our initial velocity equals to 10, positive 10. The building is the height, this is the height, 30 meter high, and the ball just missed the edge of the roof on its way down. Okay, so calculate the maximum height of the stone from point A, meaning that we want to find S, the displacement from A to B. Okay, we want to find. So before that, we need to get 3 information first. The first information is U equals to 10. Okay, the second information, of course, is 9.81, the acceleration due to gravity. And when we say maximum height, still remember, when you say maximum height, your V at maximum is equals to 0. So we also get the third information where your V equals to 0. So we have V, G, U, and we want to find S. Okay, we can use V square equals to U square minus 2GS. Okay, V equals to 0, U is 10 square minus 2G 9.81, S is the displacement. So our S, you will get the value after calculating, you will get 5.1 meter. Okay, and the value should positive because from A you go to B, or A is the origin. A is the origin 0, 0. So A to B you will get positive 5.1. Okay, B, the time taken from the point A to C. Okay, so A to B, B to C. We want to find the time taken. Okay, so we have two ways. Either you find the time taken A to B and then you times 2, or you can straight away find A to C directly. Okay, so if you want to find the time taken from A to C directly, so we need to find another information, because just now this information is from A to B. So now if you want to find time taken A to C, you must find another 3 information. So the first information is U equals to positive 10, and then of course we have G 9.81, and then we have the displacement, okay, where A to B is positive 5.1, and then you go up, and then from B to C you go down again, negative 5.1. So it will go back same line with the A, the same point. So your displacement actually equals to 0. And then we want to find the time taken. So we have U, G, S. We want to find T. We can use S equals to UT minus half GT squared. S equals to 0. Then T we want to find negative half 9.81 T squared. Okay, so your T, after you calculate, you will get 2.03 seconds. Okay, so this is question number 5B. Okay, next one, 5C. Time taken from point A to D. Okay, so just now A, B, C, then we go further downward. Okay, so you need to find another informations for A to D. Okay, so from A to D. So I use red pen. Okay, A to D, meaning that you're going up positive 5.1, you're going down negative 5.1, and you're going another 30 meter going down until you reach D. So our displacement actually is equal to negative 30. Okay, U equals to 10 and G equals to 9.81. So we want to find the time taken from A to D. Okay, so we can use S equals to UT minus half G T squared. So you substitute inside negative 30 equals to 10T minus half G is 9.81 T squared. So finally you will get answer is equal to 3.69 meter per second. Meter per second. Okay, last one we will go to questions number 5D. Okay, 5D, find the velocity of the stone when it reaches at point D. Okay, so this one we want to find V. So V equals to U minus GT. V we don't know. U 10 minus 9.81, and the time taken when you reach point D is equals to 3.69. So finally we will get our velocity equals to negative 26.2 meter per second. So again, negative here shows that the object is acting downward. Okay, it's acting downward at the end. Okay, so that's all for today. Hope you understand. Okay, thank you class. See you in next lesson.